Bismillah ar-Rahman ar-Rahim. So today we are going to take a look at the 0625 March 2023 paper 42. So that's the extended paper for the theory. We won't be doing this in detail as in each and every single question because we only have today and tomorrow to wrap things up. So we're going to focus on maybe perhaps some of the more technical challenging questions or the one that require a bit of processing, stuff that is purely from memory. We'll just skip, right?
Yeah.
You can see the screen.
Yep.
Okay. So let's get started. Right now, they're announcing what each question, right, which area of the syllabus each question covers, and so you can access those particular files from memory. So this question is about gases found in clean, dry air and gases found in polluted air. Right. So one gas found in clean, dry air, which also clean, dry air, which contributes to global warming. And so that is CO2. So that's from memory. Percentage of nitrogen. So that's 78%. Name the substance used to remove sulfur dioxide in flue gas desulfurization. This is also from memory. Do you remember?
Yeah.
What's the substance?
Right.
Nitrogen?
Hmm?
Nitrogen or oxygen?
Using oxygen to remove sulfur dioxide from in flue gas desulfurization. They're not talking about the process, right? What substance is used in that process, right? So that is
Calcium oxide?
yes,
Convertants?
calcium oxide. So nitrogen dioxide is formed in car engines. Name the equipment in a car exhaust used to convert NO2, used to remove NO2 that's formed in car engines. That is the
Catalytic convertants?
yes, the catalytic converters. I'm not writing that down. All right, all gases diffuse. Choose from the list of formula the gas which diffuses most quickly, right? And so the answer for this is CH4, and we need to look at the MR, right? So the lowest MR means the highest rate of diffusion, right? And that will be your answer to E part 2. State one adverse effect of carbon monoxide on human health.
It can affect the respiratory system.
Right now, the answer that they give in the mark scheme is that it's toxic. Right now, toxic is not an adverse effect on human health. That is a property of the gas first, right? So I don't understand. What I would do is right, go with harams, so right, respiratory ailments. But again, right, just to be clear, this is what they've given the mark scheme. All right. Carbon dioxide is a reactant in photosynthesis. Name the two products of photosynthesis.
Glucose and oxygen.
Right. Glucose and oxygen.
That was quick.
Yes. Oh, by the way, I should come back and say over here, since they're saying name, and I've written the chemical formula, you want to write the name, right? So this will be calcium oxide, and this will be carbon dioxide. Okay. They would possibly allow this, but you want to do it if you can as they want you to, so that you can secure those marks. All right, complete the dot and cross diagram for a molecule of CO2. Right, show outer shell electrons only. So what do we have over here?
How many electrons are there in carbon?
Well, you need to complete 8. Right, carbon has 4. Carbon has 4, oxygen has 6.
We are gonna draw an X and a dot in the between.
In between, so just one X, one cross and one dot?
No, like 2.
2, right? Now, an easy way of
And
doing
the other
this,
side is like
as far as the bond is concerned, because the overlapping region indicates the bonded region, right? The sharing of the electrons. And so an easy way of doing that, excuse me, sorry, just a sec. But as I was saying, you can draw the regular sort of like displayed formula if you know how to. And so that will tell you, oh, so there's a double bond. And so that means 2 pairs. So each covalent bond is a pair of one electron coming from each atom. Right? So that's, so you've got 8 for carbon. So there's not going to be any unbonded electron for carbon. Now, what about oxygen? Right? It's supposed to have, right? It's got 4 over here, 2 of its own and 2 from carbon. So that's 4 electrons, and that means there's 4 electrons left. Now, choose whether you want it to be a dot or a cross. And so what you're going to have are 2 unbonded pairs for each oxygen. Right? And so you can count it up and check. So you've got 4 and 4, 8, 4 and 4, 8, and 4 and 4, 8. So everyone's happy. All right?
Yeah.
All right, question 2. Lithium, sodium, and potassium are group 1 elements. Name the type of bonding in these elements. Well, you could go with, I believe they're asking for metallic, right? So in these elements, I was going to write ionic, but that's how they bond with non-metals. So that's metallic bonding. Sodium reacts with cold water to form hydrogen gas and a solution of a strong alkali. State the test for hydrogen gas, right? So using a lighted splint. And you're going to hear a pop sound if it is hydrogen. Suggest the pH of a solution of a strong alkali. What's the pH of a strong alkali?
8,
8 is weak.
then 12 or 14.
14, right? Just go with the strongest because they haven't specified how strong, so just go with the strongest you can, right? 14. Name a substance which can be used to confirm the pH of a solution of a strong alkali, right? So you could, right, because they're saying the pH of a strong alkali, so the best is a universal indicator, right? Because they want the pH, they don't want just a color change, right? Because methyl orange or thermophthalene or litmus paper or anything else is just going to show a color change when going from acidic to alkaline or vice versa, right? So universal indicator has that color range for different pH of solution, and so that's what you want. Write the symbol equation for the reaction between sodium and cold water. Right, what's going to be the equation for sodium and cold water? Right, so obviously the reactants are, sodium, and you want to include state symbols, so you're going to have a solid, and you're going to have water, so that's a liquid, and then you're going to have at least hydrogen gas, right? And you're going to have a strong alkali. So what's a strong alkali going to be?
At
A
least
strong alkali?
you can say Haram.
Go on, Haram.
What were you saying?
Right, so they tell us, and something we should know, right? Sodium reacts with cold water to form hydrogen gas and a solution of a strong alkali. So the equation that we're writing down, we've got sodium, we've got water. Obviously, you can't indicate that it's cold in the equation. We've got our hydrogen gas. What will be the symbol for the strong alkali? What strong alkali are we getting out of this?
And
Sodium hydroxide. And that's going to be aqueous, so AQ over there.
here
Now we need to,
equations on the side.
sorry, could you repeat that?
But like now we have 3 hydrogens on the product
Yeah,
side.
so we need to balance this,
Okay.
right? So we've got 1 sodium, which looks okay, right? And then 2 hydrogens and then 3 hydrogens. So that's problematic. And then 1. So, right, we've got more hydrogens on the product side. And so if I make this 2, that's 4. And that's 2 over here as well. That's 2 oxygens and 4. So to balance this out, I'm going to put a 2 here. So that's going to be 2 oxygens. That's going to double my hydrogen here. So that's a total of 4 hydrogens. So hydrogen balances out. Oxygen is balancing out. So there's 2 and 2. And now the sodium is doubled. I'm getting 2 sodiums here. And now it's balanced. Do you concur?
Yeah.
Okay. Lithium has 2 naturally occurring types of atoms, lithium 6 and lithium 7. Right, state the name given to the same element with different nucleon numbers, so that's isotope. Right, complete table 2.1 to show the number of protons, neutrons, and electrons in the atom of lithium shown. Right, so let's check the periodic table. Right, we've got lithium 7, and it's got 3 protons. Right. So this is going to have, both are going to have 3 protons. This guy is going to have 3 neutrons. This guy is going to have 4 neutrons. And it's going to have 3 electrons. How many electrons for the other guy?
Mhm.
Hmm?
Wait. 2?
Yes. Note the plus. So it's an ion. It's lost an electron.
Yeah.
Okay, table 2.2 shows the relative abundance of the 2 naturally occurring atoms of lithium. Calculate the relative atomic mass of lithium to 1 decimal place. How do we do that?
We are gonna add it, then we are gonna add the molecular mass and then divide it.
Okay, so it is, right, basically,
Isotope mass multiplied by relative abundance divided by 100.
right, so you got 6 into 10
Plus
plus
7
7
multiplied with 9.
into 90 over 100, which is giving us how much? 690?
Yeah, over 100. Which gives us 6.9.
6.9. Because it's relative atomic mass, you don't have a unit going in over here. Okay. Potassium oxide is an ionic compound. Complete figure 2.1 to show the electronic configuration of the ions in potassium oxide. Right? Show the charges on the ions. So first of all, the charges over here, this is going to be a plus because it's definitely, right, potassium has 1 electron to lose each.
And
And
for the second, add 2 minus sign. Yeah, and 2 dots to the outer shell of vaccine.
okay, so how many shells does potassium have? Right, so going back to, it's in what's this called? I'm forgetting. This is group and
Huh?
what's the name of the horizontal line in the periodic table? It's slipping my mind. Period. Right. So
Yeah.
so potassium is in period number 4 and oxygen is in period number 2. Right. So this has 2 shells. So we're going to add a shell. Not very neat, unfortunately. Try again. Okay, that works. And it had 4 shells, and the last shell, the 4th shell, had just a single electron. Right, and it's lost that electron, so we're going to show 3 shells. Right, and then the 3rd shell over here is going to have 8 electrons as well. Similarly for this guy. And this guy had 6 electrons. And it's got into from potassium. So you remember to put in 2 crosses. Oh wait, I made it the other way around. It's supposed to be crosses and dots. Yeah, so anything to look out for. So you're going to have crosses. And a dot here. And a cross and a dot here. Okay. Okay, the Haber process is used to manufacture ammonia. State the main sources. Skip that. Okay, the equation of the Haber process is shown. All right, the reaction is reversible. The forward reaction is exothermic. It's giving off. State what is meant by the symbol delta H. Skip that as well. That's enthalpy change. The forward reaction enthalpy change is minus 92 kilojoules per mole. State why the value shown that. State why this value shows that the forward reaction is exothermic, right? Because it's giving a negative value, which means that energy is being given off. Okay. State the typical conditions again from memory, so skip that. Complete table 3.1 to show the effect, if any, when the typical condition, the Haber process, are changed. Use only the words increase, decrease, or no change. So if the temperature is increased, effect on the rate of the forward reaction, right? Which means going from the product to the reactant. When the temperature is increased, right, the effect on the forward reaction is that the rate increases. Okay. No catalyst, the rate decreases. When the pressure decreases, right, what will it be? Increase or decrease?
Right.
Right. So this is the reaction happening. If we decrease the pressure, what will happen to the reaction? The rate of the forward reaction. So this way.
Could you show the table again? Right. Okay. The temperature increases, so it decreases, and for pressure decreases, it also decreases.
Yes. Right, because for gases, higher pressure favors the side which has the lower number of moles, right, or molecules. So if our pressure is decreased, it's going to right, not favor the forward reaction.
Yeah.
Okay, what about the effect on the concentration of NH3 at equilibrium? Right, so remember rate and right. So you're going to increase the rate of forward reaction when increasing the temperature, but it's also right exothermic. So that's also going to cause the backward reaction, which we're not talking about in that particular table, right? Because it's exothermic, it actually prefers lower temperatures because it's giving off heat. So if you're putting in more heat, right? It's also going to cause the reverse. Okay. So
Yeah.
are we going to get more ammonia at equilibrium or less?
Mm. So for the first one,
Hmm.
it decreases,
Yes.
and for the second one, right, the second one also decreases.
Yes, and the reasoning for this one is that since, right, the forward reaction is not favored due to a decreased pressure, you're not going to get as much ammonia. And what about having no catalyst? How is it going to affect the equilibrium concentration?
Wait, a catalyst only increases the rate.
Exactly. So it doesn't affect how much you're getting, it affects how quickly you're getting it.
Yeah.
So is it going to affect the concentration at equilibrium?
No.
No change. Good. Okay, explain in terms of collision theory why increasing temperature increases the rate of the reaction. All right, so more kinetic energy, more frequency of collisions, more successful collisions that have the activation energy to actually go through with the reaction.
Yeah.
Okay, ammonia reacts with an acid to form ammonium sulfate. It's a sulfate, so what's the acid? Sulfuric acid. State 1 use of ammonium sulfate, that's from memory, right? You could say fertilizer. Calculate the percentage composition, that one's easy. By mass of nitrogen, so you get the total MR, right? So you get mass of nitrogen over MR, right, into 100 and whatever you're getting out of that. Okay. Was that clear?
Yeah.
So copper is element 29 in the periodic table. Brass contains copper. Name the other metal in brass. All right. So the answer to that is
Zinc.
zinc. Okay. Right. And state the term given to a mixture of metals, alloys. Copper can be stretched into wires. It conducts electricities. What's the property?
Ductility.
Ductility. Okay. Name the particles responsible for the conduction of electricity.
Delocalized electrons.
Yes, electrons. Right. Or more specifically, delocalized electrons. Copper is a transition element. Some physical and chemical properties of transition elements are shown, right? So they've got high density and high strength, and they form colored compounds, and they have ions with variable oxidation numbers. State one other physical property of transition metals.
They are shiny.
Huh?
They are shiny
I mean,
or malleable.
that's all metals. We're talking about transition, but what's special about transition metals? Being shiny or lustrous or malleable is pretty much all the metals.
They have properties of both metal and non.
No, those are metalloids.
High melting and boiling points.
Yes, so just mention one of them, right? High melting point, right? A high melting point by definition will tell you that the boiling point is going to be high as well. So that's just the same thing. State one other chemical property.
They usually form ionic bonds.
That's again all metals.
Catalytic
Yes,
activity.
yes. Catalytic activity. So they're used as catalysts. Okay. Hydrated copper to
Are we?
sulfate. Huh?
How much more is left?
Oh, a lot.
Damn.
Yes. In fact, no, not a lot. Ah, okay, not a lot. We're almost through, in fact.
Okay.
This is the extended paper, right? Yes, March 2023. So from our syllabus. Okay.
Yes, because we have been skipping questions, so you
Well,
were thinking
kind
how.
of. Yeah, well, kind of skipping, but yeah. Okay. Hydrated copper to sulfate is a colored compound. And if we manage to complete this within this class, the time you have is 1 hour 15 minutes, and that's basically how fast you need to be going in the exam as well.
Damn.
Yes. On
Word.
your fingertips. On your fingertips. Not like skipping and going fast, like answering everything and going fast. Okay. Okay.
Those are gonna be
So
something.
yeah, hydrated copper to sulfate is a colored compound. It exists as hydrated crystals which contain water molecules. State the term given to water molecules.
Water of crystallization.
Water of crystallization. Okay. State the color of hydrated copper to sulfate.
Blue.
Blue. Right. What's the formula? Right. So obviously CuSO4. When you put a dot, and how much do you have? So this is from memory. Right. It's 5H2O.
Yeah.
Okay. Copper 2 oxide is formed when copper 2 nitrate is heated, so it's decomposition. State the class of oxide to
Basic
which.
oxide.
Basic, okay.
Basic
State the
oxide.
meaning of the Roman numeral 2 in the name copper 2 oxide. Right?
The numeral 2 indicates the oxidation state or
Oxidation
valence.
number. Oxidation number.
Yeah. The copper. What else? It
Oxidation
has a charge
number
plus 2.
of copper is +2. All right, a bit of calculation. So we need to slow down now. Well, not too much. So 0.0200 moles of copper nitrate, copper 2 nitrate is heated. Calculate the mass of 0.0200 moles. Right, so first we need the MR of copper 2 nitrate, right, which is copper, nitrogen, oxygen. So copper is 64, nitrogen is 14, oxygen is 16.
3.75.
Huh?
3.75.
The answer?
Yeah.
3.76 actually.
Yeah. I'm actually using a calculator, so that's why.
Well, a calculator should be
Yeah.
so. Right, so what you first get the MR of CuNO3 twice, right? And copper is 64, nitrogen is 14, and oxygen is 16. You do the math, right? And then you multiply that by 0.200, and you should get 3.7. How much?
5?
Six.
Oh.
6.
Does it matter?
It does.
Okay.
We have to multiply the mass of NH3 by.
Could you repeat that, please?
We have to multiply the mass of NH3 by.
Yeah, so to multiply the relative molecular mass of copper 2 nitrate with the number of moles used, right? Because whatever mass we're getting in grams is 1 mole, right? And so those are the moles used, and so you can get the mass in grams that you have. Okay, calculate the total volume of gas in dm cube at RTP produced when 0.200 moles of copper 2 nitrate is heated. Right, so you've got, right, so 0.0200 is giving you times 0.0200 moles of oxygen and 0.0800 moles of nitrogen dioxide, and that will add up, give you 0.100, right? So total volume equals to, you do the math over here obviously, and it's going to give you 0.10, total moles, and then volume equals to, you multiply that by 24 dm cube, and what
1.20 dmq.
Yes, 1.20. Okay, powdered aluminium reduces copper to oxide. Just a sec. Christopher. Okay. So write the symbol equation for this. So powdered aluminium, right? Copper 2 oxide. So CuO plus aluminium. What are you going to get out of this?
Al2O3 plus 3Cu.
So we need to balance this. How do we balance this?
We gotta put 2 in Al and
Like that.
yeah.
All right. So the first thing you did was balance the aluminium, right? And then you got 3 oxygens. The oxygens with the copper over here. So you put 3 there. So you got the aluminium and the oxygens balanced out. The copper is now 3 on the reactant side. You just put a 3 on the product side, and so that was straightforward. All right. I believe this is the last question of the paper. Okay.
Let's go.
Yes. Propane, propene, propane 1-ol, and propanoic acid are members of different homologous series. Molecules of these substances contain 3 carbon atoms. Explain why members of a homologous series have similar chemical properties.
Because of the same functional group.
Good. Name the homologous series to which propanoic acid belongs.
Haram, you know that?
Acid.
Right.
Organic acid. Come on.
Carboxylic acid?
Yes. State the general formula of the homologous series to which propanoic acid belongs. This is from memory, but I'll still ask. What's the general formula?
CnH2n plus 1. Right.
What else?
CnH2nO2. Right. COOH.
Right, and so that is a reminder for you to know your formula, your general formula.
Yeah.
Okay, propane 1-ol has an unbranched isomer. Name the isomer.
Propan 2-ol.
Yes. Now here's the question. Why is this unbranched? Because when they talk about branches, they're talking about carbon atoms, right? Carbon atoms going off to the side, right? The functional group, if it's moving off to the side, it's not called branching, right? But if you've got chunks of the carbon, backbone, so to speak, or the carbon chain going to the side somewhere, that's called branching. So although the functional group has shifted, it won't be called a branched isomer. Now, displayed formula. So we've got 3 carbons, as they've mentioned in the question. Where is the functional group coming in? It says 2, so you count from either direction, right? It's going to be the same.
3 H on the first carbon.
Right,
Yeah.
3 hydrogens here.
OH, and the second one, the H is gonna be below that. Okay. Yeah.
Right, in fact, to
Let's
be
go.
more particular, okay.
Either way is fine, right, sir?
Well, being more particular is obviously better.
But no harm in doing the first one, right?
I'd say go with the expanded version.
Okay.
They'd probably allow it, but then let's not bank on that. Okay, propane and propene can be manufactured by heating decane, right? So they're talking about cracking in the presence of a catalyst. One other product is formed. Complete the equation. So you've got decane You've got propane. So propane would be C what?
C3H8.
H8. Then you've got
And
propene,
propene
which
would
is
be
C3
C3H6. H6.
H6. So you've got right one other product. So the carbon should add up because it's like right. So you've got
Butene?
3 and 3. Right, so that's 6. So you've got 4 carbons left out of 10. So that's C4. And out of 22, you've used up 14. So you've got how many left?
8.
So C4H8. Okay. Name this process.
Catalytic. Yeah, catalytic.
Just cracking would work.
Okay.
Okay. Propene forms a polymer named polypropene. Draw the displayed formula for a section of polypropene showing 3 repeat units.
Mm. So wait. Are there gonna be 6 carbons?
So propene is this guy, right?
Yeah.
And so you need to get your
Mm. Honestly, wait. Let me think about it. There will be the structure in this. There will be a methyl group on every second carbon atom, like CH3.
just a sec. So the first thing you want to do is to draw propene such that the double bond is the focus, right? So on the side you make that, and this guy has an H over here and a CH3 over here, and then this guy has 2 H's. So that is the monomer unit, right? And it's C3H6. And so when you open that
Yeah.
up, right? So 1, 2, and those are 3 repeat units. You've got a CH3 here, then you will have a CH3 here, and you will have a CH3 here. And the rest you're going to fill out with hydrogens. Just make sure your bonds are all correctly filled out. There's 1, 2, 3, and 4 bonds. 1, 2, 3, 4. 1, 2, 3, and 4. Right. So a hydrogen here, and you're going to leave it like that, right? Because this one is showing 3 repeat units. All right.
Yeah.
Okay. So state the type of polymerization that occurs when propene forms polypropene.
Addition.
Addition.
Yeah.
Oops. All right. Propanoic acid reacts with aqueous sodium carbonate to form a salt. Right. Suggest the name for that salt.
Sodium propanoid.
Yes. Suggest the formula of the anion of the salt.
CH3, CH2. COO.
And a minus sign is important because it's the anion.
Yeah.
All right, last 2 marks. No,
But not
4
least.
marks. Propanoic acid forms an ester when it reacts with ethanol in the presence of a catalyst. What is a suitable catalyst?
Wait. Sulfuric acid?
Okay, so it could be any
Wait.
inorganic acid. For example, phosphoric acid. You could even get away with just writing acid. Okay,
Uh-huh.
name the ester formed.
Ethyl propanate.
Yeah, so when naming, the alcohol name goes in first.
Oh, ethanol, yeah.
Propanoate. But now the displayed formula. For the displayed formula, the carboxylic acid will come in first. Right? So because it's propanoic acid, you've got 3 carbons, right? And we're going to have what? 3 hydrogens here,
Yeah.
2 hydrogens here, and then what else on the third carbon?
Double bond of O on the up.
We're going to double bond O over here and
A single bond of O.
okay, and then we're going to have the ethyl
2
group.
carbon. Okay. Yeah.
And so you've got your ethyl propanoate. And we're done.
Bye bye.
Right, and so on the clock that's about 42 minutes or so, right? And so out of 1 hour and 15 minutes, we still have 20 and 15. That's 35
Damn.
minutes. Yeah, we still have 35 minutes on the clock for the paper, right?
Okay. Yeah.
Yeah, so very much possible, but obviously you need to be at the top of your game, right? So tomorrow we will similarly speed through paper 6, inshallah.
Okay.
All right.
Okay.
All right, see you tomorrow.
Okay, then Allah Hafiz.
Allah Hafiz. Allah Hafiz.